to my channel. This is my latest engine that I've been building. I started building this in about November, December last year, and it's finally completed now. It's a Grasshopper Half beam engine, and it's designed to power a Dynamo here at the back to provide electricity. It's got a double pulley wheel there next to the flywheel. It's got a 7-inch flywheel. The beam is 8 inches overall, 7 inches between centres. It's got a 2-inch cylinder stroke, 3/4 inch piston, and the eccentric strap there provides 1/2 inch of linear motion, which transfers then to 1/4 inch linear motion for the piston block. And this is the piston valve here. It's like a spool valve, so that's got 1/4 inch of motion. And I'll tell you what, I'll get some air on it and you can see it running. There we go. It runs fairly well. Quite pleased with it. It's taken a bit of work to get it up and running, as these things do. The whole engine's built from bar stock. But the only thing which was purchased was the flywheel, and that was bought from RDG. Oops, bugger. So it's a completely scratch-built engine. It's all been built from, bar stock, flat stock, and round stock, etc. For both aluminium and brass. The gears I made as well. They're 60 module 1 gears. So it was my first foray into gear cutting, and you can hear there's a little bit of, there must be very slightly out of concentric, but it still runs okay. The only thing which was bought was the cast iron flywheel, so everything else was made, and as you can see, it runs pretty lovely. So I built this nice little brass chimney, and that sort of gives it a pleasant sort of chuff noise that from the air being exhausted. I can sort of attenuate that though for the time being, just by using a pipe cleaner. But so you can hear me better over the noise. As I've explained, the rocker arm creates a 1/4 inch throw from a 1/2 inch eccentric strap, and these lever arms sort of contain the motion of the engine, so that the piston rod runs up and down parallel. So you don't get any excess wear, because it's sort of being contained by these two straps here, and obviously that creates, then you can see the oscillation motion of the arc of the engine. That sort of counteracts the piston stroke. And then of course I've done it again, look. And then of course, coming back to the Dynamo I've got here, obviously that's been driven by a 5-inch pulley wheel there, with 2 of these Mammoth style sort of spring belts. Obviously that's turning the motor approximately sort of the ratio of about 12 to 1. And then round here Oh yeah, on the top here we've got our step up power transformer. So obviously that's stepping the voltage up, you know, with the electromagnetic sort of flux. That transforms the voltage up to a higher voltage, and as you can see now it's generating quite a bit of power actually. So these two terminals now are obviously live terminals, so I don't really want to touch them, so I'll keep that turned off for now. And what I'll do is I'll connect up. I've got these high voltage lines here, so I'll get those connected up to there, and I'll put the load on, and we'll see how that goes. So people often ask, you know, whether there's drawings for my engines, but as you can see, I sort of I just have a sketchbook that I use, and you know, most of my drawings are sort of you know, just rough sketches really. So I can't really offer these out to people, unfortunately. I just tend to build it as it comes along, so I make the next part to fit the last part, sort of thing. So yeah, as you can see, that's my collection of sketches, etc. So they're not much use to anybody except myself, unfortunately. So as you can see now, it's generating approximately 1.21 gigawatts to charge the capacitor bank to power the DeLorean time machine. And on one charge, if my calculations are correct, should allow up to 4 time hops on a single charge, the ultimate electric vehicle. As the capacitor bank reaches the approximate 1.2 million volts, the flux capacitor starts, well, fluxing, and we're ready to go back to the future. So there you go. Hope you enjoyed this. I've finally built a steam engine which has a everyday purpose. Thanks for watching.